All right, yeah, let's get started. So I'm going to talk briefly here about how to read an MSDN documentation article, specifically in terms of C++ programming. So enough with the red team. We're just going to get straight into the coding. And this is kind of what I want to talk about, how to read these articles, because I think this helped me the most in my research and my coding abilities in C++. So a little bit of what I'm going to talk about. I'm going to say why, a little bit more why, other than what I just said. Why C++ over anything else, how to read the docs, and then I'm going to demo how to read the docs and actually code using the docs. So it'll be super useful, I think, and super informative. So why? Fire talks are a lot of fun, so I was super excited to give this fire talk. Enzo was like, we might be a little short this week, and I was like, perfect, fire talk time. I think this is one of the first fire talks this year. Reading docs is super essential to research, red team, blue team, understanding how a system actually works and the official documentation, not even just with coding, but with any like pfSense, any open source software or even closed source software has documentation on what it does, how it works, what specific conditions you need to meet, programming, what parameters functions take. A lot of them have this, and it's super important to be able to read this because sometimes you can find vulnerabilities, you can find misuses, or you can find another creative way to actually abuse this function. Also, on top of that, all the stuff I just aforementioned, it lets you learn more about the system. And when you know more about the system, you can potentially break the system and or secure the system a lot better than if you didn't know before. If you're trying to attack a Windows box, and you don't know how Windows works, you're going to have a hard and bad time. So actually understanding how the functions or how everything in the system functions is dire to being able to do any security on it. So why C++? Personally, I think it's best for what I do. I think it's best to write malware in C++. The graph is a little example. So this is .NET. If you're unfamiliar with .NET, it's an abstraction of the Windows API. It's a brief summary. That's how I see it, in my opinion. It does a lot more stuff, but for all intents and purposes that I see it, it is another layer of security I have to push through for my malware to work. So why use C++ for me? Because I want my malware to go around that, and I want to interact with the Win API directly. So there's a little graph of .NET Framework and .NET Core and all the different .NET fun stuff. I don't want to deal with all that. That's a lot of stuff. I just want to interact with the operating system. Also, C++, it's very challenging. It's very verbose. It takes a lot of lines of code to do some basic stuff. So I think it's fun and challenging to actually code in that. It looks cool to me. I think it's a good time. Also, when I say it's a fast language, it runs fast, unlike Python, which kind of runs slower than C++. I'm not going to get into that. That's not what the talk is about, so I'm not even going to bother getting super in-depth into that. Oh, let me check Twitch chat real quick. My phone locked. Cool. Next, some terms to know before we get into this. So the Windows API has these wonderful terms which don't make any sense to you at all if you're not a Windows programmer. So some of these essential things, I slapped a whole definition on there from MSDN. To summarize what a handle is, you cannot access directly objects in Windows, but they return a handle which has the object data, and then you can use that to modify it, look at it, do all sorts of stuff. And we'll go into debugger once I get to the demo and actually show you what that looks like in a debugger. What's this HWND? This is a window handle. So this is a handle to a window in Windows. So this is more of a visual thing. And why this is important is because we will be using this with one of the first examples that I'm showing. And then different types of strings. There's all sorts of types. What's up? Oh, nice. Cool. Did everyone miss everything? Did I have it like that the whole time? We'll go through the slides real quick for the people who, I blanked the screen for people on stream. So you could see it on stream, but not in person. Here's why. There's the graph I was talking about. There's the terms. Here's where we're at currently. Different types of strings. These are all different types of strings. All you really need to know for this talk is that Windows likes to handle all their different types of strings in different ways. It's kind of annoying. It's frustrating. It's the way the operating system works. I don't really know too much about that, why they do it. I think it's because they need to expand from the ASCII character set to display more characters. I believe that's why. I'm not 100% sure. Don't quote me on that. But from what we're going to need to know a couple of these, just because in the demo today, it's going to require it. And then there's also all sorts of different types of D words and other types of ints. Tons of Windows stuff. The documentation has everything you need to know. So afterwards, if you're curious, you can look it up. All right, so the demo time. Awesome. So the first demo we're going to do is we're going to use the MessageBox function. So now we get to the demo. So here's what a basic MSDN article looks like over here. I'll make it full screen. Ooh. So here's what the article looks like. So you got your function, and then either you'll have your header you have to include to use the function right here, or if it's not listed right there, you will see it right here. So what it does is a little description about the function. It gives you the syntax of the function, and those are all the parameters the function takes. This is a nice, pretty one. They can get really gross. There's some of them can get really, really gross, and I'm talking like 10 parameters gross. And they're all are weird Windows things. So we wanted to pick a nice, easy example to start. I'll make it a little bigger just in case it's small on the stream. Parameters. So then it continues to be like, OK, what are these parameters? What the hell do they mean? Oh, well, they're going to go through them and tell you either A, what you need to put in there, or B, what they mean. So hwin, that's what type it is. It needs a handle to the owner of the message box to be created. If this parameter is null, it's just going to have no owner. So what that means is what process is owning this message box. For example, if we have a program, and, ooh, I just hit the mic. If we have our program and we want the message box to display under that program in the task manager, we're going to give it that window. In this case, we're going to use null because we don't care. We just want the message box to be displayed. Here's this LPCT stir that I mentioned earlier. What does this mean? It means it's really annoying, and we're going to have to do a bunch of conversions to get the work. I'm not going to get into detail how to do conversions and stuff on all these because it's painful. You have to fiddle with it. There are lots of resources out there of how to convert, how to deal with these types of things. I have within the demo, though, we will figure out one way to cast to these and actually get something to display to the screen. A uint, another type of integer. This one, what is it? So there's what it does. Oh, that's what it does. This is a, so for this message box specifically, there's a bunch of pound-defined things in C++ by default on the Windows operating system. These are a bunch of these pound-defined things. As you see, if I type in this, mic fell right off my shirt. Sorry, stream. If this is called, and we can pipe these together to give it multiple different types of ints so it knows what to do with the message box, and you'll see this shortly. So if we pipe a bunch of these together, this will tell what buttons on there. If we keep scrolling, this will tell you what icon. Do we want a warning icon? Do we want a warning exclamation icon? Do we want a question mark icon, a stop icon? We can also do the default button setup. We can do different types of dialogue, it seems, with this function. And we can do also different types of values. So I can do display desktop only, set the window to be the foreground window, which is the frontmost window, or the topmost. So, and then we get into the return value. So what does this function return? Well, it returns an int, and the int is matched to which type of button. So that's what pretty much a summary of what this is saying. And it even accounts for if escape or cancel is hit with the message box, it'll return an int specific to that. Here are a bunch of the return codes. Here are some of what some of them the pictures look like, just to help you figure it out. And then sometimes they're nice enough to show an example of what the code looks like. They're not always this nice, because sometimes it's disgusting. But here's a little simple way of how to use it. There's the message box function. They pass in what they want it to display. There's the icons they want. Null, it doesn't have a window it's attached to. And there's a switch statement being like, OK, what did it return? And it will do something. So that's what they had. So cool. Fun little note, important. If you have a lot of compiler error and linker errors sometimes in C++, and I'm going to purposely mess up on the demo to show you some of these, but none of these have this issue. Sometimes you will need to do a pound pragma comment and include a library to actually have the function work. For example, this function uses the user32lib library. So if you're experiencing a lot of linker errors in C++, my recommendation is to always pound pragma and comment, include, and I'll show what that looks like, the library, and that will explicitly tell the program where this is at and what library it needs, and then it will know how to compile it. It's just something that happens sometimes, depending on the function. All right, so we're going to slap this over here. So cool. We're going to start our C++ program. Let's pray this works. So we're going to start with our main. Cool. So now we need to include the header that it said. It was the WinUser.h header. I'm also going to pound include IOStream so we can print out the results to show. So cool. What do we need here? Well, we need to use the message box. We're going to do an int. We'll do result, do res, do message box. There it is. We can tab complete it. Awesome. So we don't want it attached to anything. Let's give it, oh, bad caps lock on, my bad. LPC W stir is what it says to give it in the example. Now this is going to be, if you look at the parameters, what they were called, this is what's going to be displayed in the box. So I'll say hello RITSec. And we're not going to give it a new line because we don't need to. This is going to be what's on that top part, like what's in the actual title bar of the message. So we're going to drop one of those. Oh, forgot the L. So real quick on the L. There's strings in C++, and then there's W strings or W chars. And W is what, the W chars and W strings is usually what is used in Windows to display text on the screen. This is not direly important for this talk, so I'm not going to get too in-depth into it. So we're going to just say, from John. And then we're going to scroll up here and decide what we want. Let's do a warning. So let's do MB underscore icon exclamation. There it is. Tab complete that. We want it to be topmost. So we will set it to be topmost. And then let's do a default button layout. Ooh, where'd it go? Default button layout 1. So we'll just take that, throw it over here. Cool. And then we close it off, semicolon. Awesome. So let's give it a run. So we have some errors. What are the errors? Oh my, look at all those errors. What the hell do they all mean? What are we going to deal with? So here's a quick tip I actually just learned last week. Sometimes when you include win functions, like WinUser, it has a prerequisite of including pound include windows.h. Because a lot of these libraries use things from windows.h. So you actually need to pound include windows.h above all the other stuff you need to include. And this can be confusing. So let's run it again and see if that fixed it. It's compiling. You got to give it a moment. There it is. Boom. So pound include windows.h. Right above it, made it work. It found all the stuff it needed to. That's just like the hwin variable and handle. A lot of those need Windows, and I believe the LPC whatever stirs. Those need windows.h, and that is like kind of just something you have to know when coding. So there we are. Real quick too. Let's print out our return value to the console. So we're going to use just basic cout. Let's just print the integer and then end the line, because why not? And let's run it one more time. Cool. So the message box should pop up. There it is. We only got OK or X. Let's hit OK. Boom. 1. It returned 1. Awesome. So we just read the documentation to figure that out. Pretty cool, right? So now let's get a little more complicated. Are there any questions from anybody or the stream before I move on to the second example? Alrighty. I'm going to leave this program as is because the next example is GetForeground, which needs the same user.h because it's a similar thing. So what does this do? Well, it returns an hwin. There's the return value. There could be a problem if it goes null. And if we're running it, oh, see, there it is. Include windows.h. So see, it was in there and I just missed it. They're very meticulous, this documentation. So you really need to read. If you're having a problem, make sure you read it again, because sometimes it really includes a lot of information that you just don't see. All right, so let's start with that. So we want an HWin, and we want to do my window equals GetForegroundWindow. Awesome. So what does that look like? Let's take a look. We're going to pop a breakpoint, run with debugging, and this might be a little small, but what does that say right there? For those who can't really see it on stream, right here, it's unreadable memory. So you can't really read these handles or the HWin because the memory isn't readable to you, but you can access it and pass it to different functions, and Windows will take care of reading it, which is disgusting, but that's how it works. Cool, so we got what we needed. Let me break, oh my God, there it is. Awesome, so now we need, what is it? It is a wchar, I believe. A wchar, and we're going to, let me get through what we're attempting to do. So we need to get, I want to get the text on top of the window describing what the window is. So for example, this would be Chrome or Firefox or whatever the hell the title of the window is. If it's CMD, it'd be like cmd.exe, blah, 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 blah. You just pull CMD up. It'd be this thing right here, I believe. So we need to pass it, that HWin that we just got. Cool, we have that. It returns this. It returns an LP stir. Well, it returns an int of how long the string that it put into the buffer was. So what is the buffer? This is it describes here that this is the buffer that will put the text in. So we need to be aware of how long this is so we can add an end character or print it out or all sorts of fun stuff. It could be very useful when working with string arrays or character arrays to understand how long it is. And then this is the max count of how long it's going to be. Brendy, I will get to that question right once I'm done. I will give all sorts of advice of where to start with this. So here we're going to do we're going to do window name, and we're going to do max buff. And just for good practice, we are going to do pound define max buff is 256. Cool. So all that does is it just is a definition in C, and it plops that in there. Forgot our semicolon. Okay, cool. So now we're going to get the result of that, and we're going to do get window text A. Ooh, not control A. Get window text A, and we are going to pass it my window. And then we're going to pass it a string, but it needs to be an LP stir. So we're going to convert it to that. We're going to do window name. Cool. And how long? We only are accepting the max buff. That is the maximum amount we will accept. So if it's longer than that, it's going to chop it. Awesome. So one more thing we want to do, I'm going to assume it doesn't error. Normally you want to error check, but we're not going to bother with that right now because it's just a quick demo. It returns the result, so we want to actually, just for good sake, we want to do the window name, and we want to set the result, so the end of the buffer, to be a null character. So in this way, it'll chop the string off, and it won't have any issues printing, and all that extra data won't be involved in the string. So what now? We want to see out the window name, and we won't even bother ending the line because that's the end of the program. Fingers crossed it compiles. I think I got that right. If it doesn't, I know how to fix the problems because I coded it beforehand. Oh, I placed the debug point. That's fine. We're going to take that away. Let's give it a restart and see if it works. All righty, cool. Kind of. What do we got here? It didn't know how to print it. Fun little thing about C. You need to do, since it's a W, C string. Oh wait, nope, wrong language. No. W. I believe this will fix it. If it doesn't, I'm going to pull out my cheat sheet. Time for the cheat sheet, because I knew I would forget. Okay, we're going to just pull on over here. And here's the cheat sheet. So it doesn't compile over here, but we're going to copy it on over, and then we'll run through it, and the mistakes I made while coding. Alrighty. Oh, it was just a character. That was the problem. Alrighty. So it's pretty much exactly what I just did, but with a character instead, not a W character, a W char, just a char. So now if we run it, you will see the window name. Boom, there it is. It got the window name of this debug window right here, because that's what it was before I clicked on it. So awesome. We got the window name, and again, these chars and W chars are very confusing. You see, even I just messed up. You're going to have to work with them and fiddle with them sometimes. I like to keep them all into one type. So if anyone has questions, feel free. I'm going to answer Brendy's questions. Brendy's question, for anyone who didn't see it in person, is any advice on where to go for hopping into C++ with red team and tooling in mind? So my recommendation would be to look through some of the functions. Think about what you would want to do. Think of some persistent mechanisms. Think about how you would take advantage of stuff. Think about how you would move, and then take advantage of that. Look at those functions. Setting up a socket in C++ on Windows is disgusting. I'm going to be honest. It's awful. But it's really fun to do, in my opinion. It's effective because I think C++ programs are really effective in evading a lot of antivirus just by coding your own stuff, because a lot of them are signature-based. And if you wrote your own, you just have your own signature now. There are functions like create remote thread and write virtual memory that you do want to be careful of, because Windows Defender does pick those up. But getting started, I think the best way to actually learn and do it is to practice. You have to practice what you do. I did not get good at C++ programming by just sitting here and reading this docs. You have to think of what you want to do and actually make a program. It could be simple. Write to the registry. There's write to the registry Win API functions. There's MessageBox functions. There's look at users functions. There's create user functions. There's also anything you could do in the command line that you could think of can be done with Win API, because the command line is usually calling this Win API functions. So anything you could think of doing with a script, program it. Hell, you can even use Blue Team. So any other questions on this? Hot. Well, that was my fire talk. And now